All right, Algebra 2, welcome back to Absolute Value. What we're going to do today is we're going to take care of absolute value inequalities or problems involving absolute value inequalities. AVEI1 was the equalities or the equations, the equal sign. Now we're going to do a little something different. We're going to take care of some inequality work. So let's look at what we got here. We've got inequalities involving this symbol. This is less than, if you see it like this. We're going to call this less than something. X is less than something. In this case, it's the absolute value of X is less than A. I just kind of want to also throw this out here. I'm going to write this. These are going to be and statements. Now, you don't need to know what that means right now, or you don't need to remember what that means right now. We're going to come back to it, but I want to put that out there. These are going to be called and statements, and you'll see hopefully why in just a couple minutes. We've got the absolute value of X is less than A. Now, if we do this, let's take a look at an example here. It says graph the solution for the absolute value is less than 3. What we're trying to do is the values of X that represent all numbers whose distance from 0 is less than 3. That's exactly what this is trying to say. Less than 3. And how I'm going to do this, I'm going to do this using a number line. I'm going to throw a number line down here. Okay, I got my 0, 1, 2, 3, 4. 2, 3, 4. I'm going to put my -3 and 3 in here, and you'll see why in a second. Because if I think of, let's plug in some values for X that make sense. For right in here, if I said X was 0, would that make this statement true? And the answer would be yes. So a 0 would be an answer to this one, a solution. 1 would also be a solution, so this would be okay. -1, that's an interesting one too, because that also would be okay. The absolute value of -1 is 1, and 1 is still less than 3, so it's getting in here. Well, 2 and -2 would also be, but if I get to 3, 3 is not, or the absolute value of 3 is not less than 3. Similarly, the absolute value of -3 is not less than 3. So what we're trying to say is these values go right up to the 3's, but they don't touch or don't equal -3. Remember back several targets? When it goes right up to but does not touch, we represent with that with an open circle. Now that's the ends. And we also said that the values could go anywhere in between. 0 is a value, -1 and 1, anything in between -3 and 3 are considered to be solutions. Well, that's interesting. That looks a lot like the inequality notation we've already done. In fact, it is. I've got this X value. It's got to be bigger than something, but less than something. But those still both look like less than symbols, right? The smallest number is -3. The biggest number is 3. Interesting. And if I relate that back to what we've got going on up here, this says I've got X, so stuff that was in the absolute value symbol or sign is right here. And then I've got a positive and negative value on the left and the right. And I see this inequality symbol right here, both here and here. I'm going to start a pattern because in this next one, it says the absolute value of X is less than or equal to 2. And if we think about that, once again, it's all the values that represent X whose distance from 0 is less than or equal to 2. If I graph that out, here's 0, here's 2, here's -2. It could be 2 because the absolute value of 2 is 2, which is equal to 2, which is there, okay? It could be 1, okay, so I'm looking in here. It can't be 3 because the absolute value of 3 is not less than or equal to 2. I start coming this way, 0 still works, 1 still works. If I get to -2 also works, and it also is there. So I'm going to go ahead and put a closed point saying that I could have between -2 and 2, including those values. If you remember back to Algebra 1, this looks a lot like an and statement in a compound inequality. This is my compound inequality and statement. An and goes between two values. We're going to use the same thing we did over here take the stuff in the absolute value, put it in the middle, x, draw the same inequality symbol on the left and the right of the x, put the negative of that number and the positive of that number on the correct sides. The negative goes on the left, the positive goes on the right, and I have this -2 is less than or equal to x, which is less than or equal to 2, which is the same thing that my graph said, and it's the same thing that we reasoned through when we were just plugging values in. Interesting, interesting. Okay, so let's take it up a notch. It says inequalities in the form of the absolute value of x plus a is less than b. The absolute value of x plus 2 is less than or equal to 3. So what we're looking for is the values of x where x plus 2, still the stuff inside the absolute value, is less than 3 units away from 0, or exactly 3 units away, or equal to. That's that part, right? And here's how we do this. Take that stuff in the middle and the absolute value, put it right in there. Take the same inequality sign, put it on the left or the right. Put the negative of the number on the left, the positive of the number on the right. Okay, we've got this one. Now, when we report things out, we're generally not looking for just what does x plus 2 equal, right? And same way, if I had x plus 2 equals 3, how would you solve for x? Well, you'd subtract 2 from both sides. Well, let's go ahead and make this a little different. What if this was an inequality? X plus 2 is less than or equal to 3. How would you solve for x? You'd still subtract 2 from each side of the inequality. Well, in this case, you're going to subtract 2 from all parts. So you're going to subtract it from the middle, from the left of the inequality, and from the right. Because on the left-hand side, I have -5 is less than or equal to. Well, x plus 2 minus 2, that just gets rid of the 2's, right? So this is just x and less than or equal to 1. And if you're not sure, plug some values in. Let's check -5. Well, -5 plus 2 is -3. The absolute value of -3 is +3, and 3 is equal to 3. Let's check our 1. 1 plus 2 is 3. Same thing, absolute value 3, that's equal to 3. We've got our 2 values. If I was to graph this, I would have closed points both at -5 and go to 1. Closed points because it's less than or equal to. Less than or equal to. Go ahead, I'm going to hit pause here. You're going to try number 4 on your own, then come back and check your work. All right, let's go ahead and bring it on back. We end up with, we put the stuff in the absolute value. We put that right in the middle, x minus 1. We've got our same inequalities on the left and the right of there. We've got the -5 on the left and +5 on the right. And how do I solve? How do I simplify? I would add 1 to all the sides. Add 1 to everything. I have -4 is less than x, which is less than 6. Now, your next job, I know it's going to be kind of weird. We're going to skip around a little bit here. I want you to do one more practice problem. And that number is number 12. I believe that's on the 3rd page. It is right here. Give me one more practice problem if you would. One more practice problem if you would. Then check your work when you come back. All right, if we take that same pattern we've been working through, we take the absolute value of 4x minus 5, we put the 4x minus 5 in the middle, right into here. Again, this is only going to work for the less thans. We'll see this in a second. We put our inequality symbols on the 2 sides, the same inequality symbol, put the negative value of the number on the other side of the inequality on the left, the positive value on the right, and we just solve. The first thing we do is add 5 to both sides. I'm sorry, 5 to all sides, and then we divide by 4. We end up with half is less than or equal to x, which is less than or equal to 2. All right, hopefully, and I've said this a little bit now, let's go back to that and statement. Remember, in a compound inequality, an and statement goes in between, which we just had. These go between values. This is between half and 2, including those values. What happens if we have a greater than? Well, hopefully you're remembering a little bit back to Algebra 1. That inequalities, in this case, we're going to do some absolute value stuff. Again, this is greater than, And these are going to end up being our ORs. Our ORs. And if the other ones go towards each other, ORs are probably going to go out. Let's see what that looks like. Graph the solution for the absolute value of x is greater than 3. Again, throw a little number line on here. X represents all numbers whose distance from 0 is greater than 3. Greater than 3. In other words, 0 is not greater than 3 units away from 0. 1 does not work either. 2 doesn't work. 3 almost works. But like 3, 4, 5, 6, 7. So starting at 3, 1, 2, 3, starting at 3 and going this direction, bigger numbers over here, that makes this work. Open circle at 3 going to the right. But what about negative numbers, Mr. Brayman? Oh, I'm glad you asked. I'm really glad you asked, because if I come over here to like -4, the absolute value of -4 is 4, and 4 is greater than 3. And so is 5 and 6. We're gonna have the same thing starting at -3. -1, -2, -3, this open circle, and numbers that are less than -3 also give solutions. So you're saying to yourself, how do I represent that? That's a really good question. With ands, we can write this nice one inline compound inequality. With ors, we have to have 2 statements. I like to do it like this. I've got x and one number here, x and another number here. This is an or, so we're going to put ors in the middle. And let's look at this. We got x and -3. Well, we're going to do things that are less than -3. So x is less than -3, or x is greater than 3, because we start at 3 in numbers that are greater than. Well, let's use this same knowledge here, right? It looks like what I've done is I'm going to write this. I've got x, -3.5. This is number 6, or x and 3.5. Well, let's see what I did here, 3 and 5/10. On the left side, when I had a negative value, again, this is what we do for greater than, right? I have a negative value. I also had a less than. So I'm going to make this x is less than -3 and 5/10. Or basically the other one, x is greater than 3, looks like exactly what we started with, but without the absolute value signs. We're also going to have one of those. X is less than -3.5, or x is greater than 3.5. That's it. That's all we're trying to get done right here. Now, there's obviously more things to think about. Like you got to isolate your stuff first. Same. That's, again, a similarity between this, inequalities, and absolute value equations. All right. Now we've got, what if you got the absolute value of x plus a, or something else going on in here? How do we do that? Great question. Well, number 7, it says the absolute value of x minus 7 is greater than or equal to 4. We're looking for values of x where x minus 7 is greater than 4 units away from 0, or exactly 4 units away from 0. I can take this and split this just like I normally do. It's an absolute value with a greater than or an equal to. So I've got x and -4, or x and +4. Well, the one that's the +4 needs to look exactly like the original. I'm sorry, not x, but there we go. Sorry, x minus 7 and -4, or x minus 7 and +4. Well, the x minus 7 and the +4 needs to look exactly like it did in the original one without the absolute value. And then when we flip the sign of the value, so from +4 to -4, we also need to flip the inequality. Less than or equal to. Well, it's nice we can solve these. These are one-step equations. I add 7 to both sides. I have x is less than or equal to 3, or add 7 to both sides, x is greater than or equal to 11. And that is that. So number 8 says you try. That's what you need to do. Use that pattern that we've established and go for it. All right, so what did we do? Well, we did the same thing. We set up, we've got our stuff in the middle, x plus 2 and x plus 2. We've got our -4. We had to flip that inequality. So x plus 2 is less than -4, or x plus 2 is greater than 4. Those are our two essentially inequalities that we're working with here for a greater than. And then we just solve. X is less than -6, or x is greater than 2. And that's all you got. And that's all you got. Now we're going to do the next, the part 2 will be more formal, a little more formal on some things that we're going to work with. But right now, where we're at, that's a good place to hit pause. So anyway, take care, have a great day, and talk to you later.